So as we know that human God gave us a very complex and powerful listening system, which is our ears. Through these, by listening to the sound of people talking to us, in fact, we somehow can analyze further, not only listening to what they're talking, but at the same time, we can sense the emotions behind that. So we can somehow predict whether or not they are happy or sad or any other feelings. Even when we sleep, we still can listen. And we also can interpret the sound in multiple layers. So imagine that in a situation, is a crowded situation, so many people talking at the same time, and somehow we can focus on one conversation. We can hear and understand what they are talking about, even at the crowd. Yeah. And we also can be if we train our listening capability, or somehow we can notice or use that to analyze something. I believe that you probably have this experience. When you have problem with your car, you send it to a workshop, and the mechanic or the engineers, maybe they will ask us to uh, uh, turn on the engine, because they want to listen to the sound of the engine. By listening to this sound, that somehow they can imagine how the engine is working, and due to the um, uh, a specific sound, they somehow can predict and identify which part of the engine that are having a problem. So we can train that. So there are a lot of things that you probably can look at when we want to do research in sonifications. I mean the potential application or the motivation behind that. So just for us, a brief idea about the definition of sonification. So this is based on Kramer, 1999. The definition for sonification is the transformation of data relation into perceived relation in an acoustic signal for the purpose of facilitating communications or interpretations. If we look at these definitions, there are three main elements that we need to take care of. The first one is the technique. The second one is the input and output. So you must have the input, maybe the data, and then you will be producing the output, which is the sound. So you need to identify the technique to convert the data into sound. But at the same time, you must have the purpose. What is the purpose of converting this? What is the purpose of this sound? What is the objective of converting this into sound, and what is the sound for? So just want to give you a brief ideas. I have about 10 minutes left. So I want to show you a few of the example what I've done in this research group. Yeah. So in this project, sonification of 3D body movement, we are trying to convert our body movement lively, to be represented using non-speech sound. So the problem is that, imagine we have, for physiotherapy, for instance, we have a blind person. In order for you to instruct them, for instance, to raise up their hand, they cannot see you. If you say that, okay, can you raise up your hand? So this is raising up your hand, and this is also raising up your hand. So which one that you do you mean by raising up your hand? So so you have to finally touch them, to teach them that this is actually raising up your hand, not this one. Yeah. So so what I'm trying to say here is that the speech instruction might be confusing. So in this project, we are trying to convert the body movement into a non-speech sound, so that the blind people can listen to the sound and follow the movement, without the speech instruction. So we have this project, then we try to convert that into sound, and yeah, and we are using Super Collider to do this. Just want to give you the example of the experiment. This is the first test with a single hand. So in this case, actually, this man, yeah, moving their hand. We just want, for this experiment, we just want to look into how we can convert the movement of the hand. Yeah, live. We convert the live, so meaning to say that the movement will be changed, will be detected, and then the sound will be generated on the spot, and will be listened by this lady, and then trying to follow the movement here. Yeah. Well, see, the result is not bad, but I think that definitely we still need to refine this. This is just an earlier stage. We want to see whether or not this can be done. Yeah. This is to follow the instruction. So this is for both hands. So what will happen if we want to use both hands? So it's going to be even more complex, because you have a lot of point that you need to convert into sound and need to be heard by this person. Yeah. So we're using this connect to check the movement directly, and then it will be listened to this person directly. Yeah. Okay, so if you can see that it is so far, well, not bad. You still can somehow they still can follow the movement of the hand. All right, that is 3D movement. So the second one is the sonification of GEO-VISUALIZATION for complex dengue data. So in this project, that we want to check, whether or not we can do or help the doctor. In this case, we are actually working with a doctor in the hospital to see how they can do analysis besides looking at just the visual on board. So can we just help them to to display as many information as possible at the same time. So we want to put everything in one visual screen, so it's going to be maybe difficult for them to look through everything. So not everything can be put under one screen. So the idea is that, can we change any of those important factors to be represented as sound, rather than just visual. Yeah, this is how the sound can be used to complement visual in terms of analysis. So not only for dengue, in fact, this is also maybe can be used later on for COVID-19, so how we can understand, how these uh, pandemic uh, being spread in the area, in a specific area. So this is what we do. Um, we have all the factors, all the data, properties for these dengue data sets, then the properties of the sounds. So we apply parameter mapping to this, then we create this prototype, and then we ask the doctor to check Yeah, so I just want to give you this, a very fast one. I will just track here. Then you have to do all the setting, and the data, if you look at here, the data is in weekly basis, you know, and then we have the we play the data being collected for 50 weeks, you know, with all these setting. Yeah, just want to give you an example of the sounds that you can hear. This is audio and visual. All right, this is just an example. Okay, I'm running out of time, so I will just skip this. This is another one. It's just sound, so maybe if I can just put that. So that is, this is just sound without any visual information. Yeah. All right. So based on this experiment, we found that somehow this sound, the doctor said that it's quite help in terms of, you know, to help them to interpret, you know, based on their knowledge, what is going to be happening, you know. So yeah, definitely this is another project that we're going to expand further. Yeah, and we have this also to understand the sound through Kansei engineering methodologies. So as we know that, you know, if you have this kind of situations, the reason why you want to you know, if you want to buy a new car, you normally open the door and slam it because you want to listen to that sound. And if the sound is like boom, then you feel like, you know, safe. Yeah. So so that's the word safe is actually the manifestation of the emotions based on the sound that you hear. So if we can design that sound purposely to trigger that kind of information, that will be very helpful in terms of, you know, for product design. So this is what we're trying to do in this research. Yeah. So we for the sound we try to you know, analyze and synthesize, we separate the sound into sound properties, and then we want to look at which one will trigger which emotion. Yeah. So as a result, so we can play around with the properties for the specific emotion. So we try with the ocean wave. With this is the results, you know, through by changing the volume, frequencies, and tempo and harmonicity, you know, of the ocean wave sound. So we can play around with the emotion. And we tried this with Harley Davidson, is a motorbike. You know, people love the sound very much. You know, the sound is potato, and it's a potato, potato, potato. This is the motorbike, Harley Davidson. So people love that. Then we try to analyze it by, you know, separate that sound into volume, tempo, and frequencies, and then try to find out which properties that will influence of certain emotions. So we have these as well. Yeah. But do you know, people love these Harley Davidson because the sound is annoying. All right, and this is a very fast one. And then this sound ability among dyslexic people. We also want to find out the sound ability for the dyslexic people. Dyslexic is someone who has these learning disabilities, confused with left and right. So you want to see whether or not these sound representations can help them. Yeah. So we have the experiment with the kids, you know. Yeah. When you have the experiment with the kids, it must be very attractive, striking colors. But the result shows that, you know, for the certain tasks using sound, dyslexic perform better than a normal people. So this is something that you probably can look at. We can look at how this sound can be used to help them for in terms of learning purposes. So finally, I hope that this auditory display all notifications to be available as naturally as today's mouse and keyboard interface. It's not only just to, when you open the PC, ting, 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 there's just the sound, or as the indicator you're doing things as in queue, or just for that. So we just hope that it can be beyond that. So I hope also that sound in human computer interfaces to be much better designed, more informative and better connected to human action than today. So I think with that, I thank you very much for listening. And I just hope that, if you have any questions, you probably can ask me after this. And if you are interested to, for future collaboration in terms of research, or if you're interested on certain things, because the artificial intelligence or any other research field, in fact, can be incorporated into this, topic as well. So we can join doing research together. So I can be contacted at this, if you look at the slide, at ewgsri@ums.edu.my. Right, I think that's it. Thank you very much.